A big thank you to the organizing committee for including me in this privileged group of presenters on the main stage. Sadly, I'm not standing on any stage, of course. I'm only sitting at my desk in Nicosia, Cyprus, where my work has been conducted for the last 13 years. So it includes several aspects of maritime and underwater archaeology, from teaching, training, and public awareness to fieldwork and research. No matter how many different projects my team and I get involved in, however, there's only one that I'm always invited to talk about. And today is no exception. My topic is, I cannot change my slides for some reason. Yeah. So my topic is the Mazotos Shipwreck, a 4th century BC site off the south coast of Cyprus near the village of Mazotos. There are several good reasons for the popularity of this site, I believe. It is an undisturbed wreck, or was before we started its systematic excavation, at a difficult but not impossible depth for divers. For Cyprus, it is only the second excavated shipwreck after the legendary Kyrenia ship, which marked a watershed for shipwreck archaeology in the Mediterranean. Furthermore, good photography, photogrammetry, and 3D applications, visual applications, were used from the beginning of the project, something that fit very well in the new era of digital archaeology that emerged more or less when the project started and has expanded exponentially ever since. Another characteristic of this project is that it has lasted for quite a few seasons. As my title indicates, it's already 13 years and many dives old and still ongoing. This year is the first full study season, however, so most of the material remains essentially unpublished. Therefore, for today's presentation, I will focus more on methodological and interpretative approaches. Not only because I still have no definite answers about issues like the exact number of cargo amphorae or the full extent of the preserved hull, the framing system or the masthead, etc., but also because shipwreck archaeology in the 21st century goes beyond hull details and diving challenges. It should be how we use the tools and technology we have at our disposal to answer old questions or to ask new, more challenging ones, as well as about inclusiveness and bringing the public closer to our deep and wet shipwrecked world. The discovery of the site was not an archaeological achievement. It was reported to the authorities in 2006 by 2 divers who were using it as a rich reserve for fishing. Soon after, the University of Cyprus undertook the first preliminary investigation under the direction of Professor Dimitrios Michailidis and myself. Excavation only began 3 years later, after a period of surveys that helped us establish the basics of the ship's identity. It was clearly an Aegean cargo, with hundreds of ceramic transport containers, what we commonly call amphorae. Thanks to good previous work on amphora studies, we knew that they belonged to a well-known type from the island of Chios in the Aegean, that they most probably carried wine, which was the actual cargo of the ship, and that they dated to the first half of the 4th century BC, almost in the heart of classical antiquity. So in 2010, after the 3 years of surveys I mentioned before, I should have found myself faced with one of the main existential dilemmas that 21st century underwater archaeologists have in front of a shipwreck: to excavate or not to excavate. The 2001 UNESCO Convention prompted us to be cautious with invasive processes when they are not absolutely necessary. But as it happens, more often than not, promising finds like this one are not always discovered after a full survey is completed in the region. So priorities for excavation cannot be set based on justifiable parameters that take into account fully mapped waters. Besides, the convention also tells us that excavation can be authorized for the purpose of making a significant contribution to knowledge. I can assure you that there are so few ancient shipwreck excavations in the Eastern Mediterranean that any such endeavor would make a significant contribution to knowledge, as well as to protection and enhancement of underwater cultural heritage. Thus, although it is true that excavations are costly, destructive, logistically complicated, and they entail dedicated long-term commitments, in 2010, the enthusiasm in Cyprus was overflowing, and all involved parties were keen to start digging. Thetis Foundation provided the necessary funds, and the University of Cyprus the proper scientific affiliation and support. So I confess that back then I did not actually have any dilemmas regarding excavation. How to excavate is the second important question that has to be dealt with if the answer to the previous one was affirmative. Water dredges and airlifts are pretty much bog standard tools around the globe, so my question obviously did not concern the excavation mechanics. It concerned the methodological approach. Survey before excavate. This box was ticked. Apart from the good photogrammetric mapping of the site, a geophysical survey had been conducted in 2009 in collaboration with the University of Patras in Greece. Remote sensing at a radius of 500 meters showed that there were no other associated finds in the immediate vicinity. Through a magnetometer survey at the site itself, we tried to identify concentrations of buried materials other than the visible amphorae, namely concentrations of metals or stone. The results were elucidating. The site was not dispersed. It was almost certain that layers of cargo amphorae were sitting on what had remained of the hull buried underneath them. An area with strong magnetic signal, on the right on the slide, was located at one end of the site, and this was actually where we started the excavation later on. In other words, we opted to start from the most promising part of the site. What this survey had actually confirmed was that one of the most important aspects of the Mazotos shipwreck was its stratigraphical integrity. The ship seemed to have sunk in an upright position, which it more or less preserved on the seabed. It was not capsized during wreckage, and the mariners did not jettison the cargo items in the water in order to prevent sinking. After the wrecking episode, the ship reached a sandy, flat seabed, so the site was not scattered. It underwent a natural process of degradation without major disturbance from human activity. It was not looted, not much at any rate. The transport amphorae were there, although the cargo itself, i.e. the wine, was regrettably gone. In other words, it was one of the sites where the phrase excavation is destruction finds its perfect fit. Therefore, our focus from the very beginning was not to destroy evidence of any kind possible, finds, stratigraphy, environment. We were all familiar with the theory of site formation processes, of course, but I still remember how touched I was when I read an article about the death of the Titanic in a 2012 volume of the National Geographic and thought that one day we could do something similar with the Mazotos ship. I can tell you that we're still miles away from that day, but these pictures may help you understand why we chose to be so meticulous with mapping while we're conducting a catastrophic but fascinating process, that of excavation. Photogrammetry was used extensively from the beginning of the project, and I'm proudly showing you a vintage 3D created with Photomodeler before Agisoft Photoscan was released. Photogrammetry itself, of course, was nothing innovative in 2007. It had been introduced in shipwreck excavations already in the 60s. But our goal was not to create an attractive 3D plan or just replace tape measurements for sections and plans. What we tried to do was to create a dynamic platform for post-excavation research and multi-level interdisciplinary documentation of the shipwreck sites, cultural and natural environment. Before I discuss some side projects that demonstrate this approach to 3D applications, let me introduce the site first, having included the results of the most recent field season. Excavation at the two extremities of the site, i.e. the stern and the bow areas, have exposed parts of the keel which was broken at its aft end, but was preserved until it joined with the stem at a total length of 15.3 meters. In 2019, we completed the excavation of the bow area and proceeded toward the main hold. After 133 partly or fully preserved key and amphora were removed, a good part of the starboard side of the hull was exposed, including the keel and 8 strakes, with 6 frames and a stringer in situ. This was the largest part of the hull excavated so far, and its study is still in progress. Nonetheless, it has already provided sufficient evidence to place the ship in its broader technological and cultural context in a way that complements our limited knowledge for shipbuilding traditions in the Eastern Mediterranean during the classical period. The exposed hull section suggests that the Mazotos ship was a round bottom one, with sparsely placed frames, although the pattern seems to change toward midships. To these rather archaic features, another one can be added. Tetrahedral openings for ligatures combined with pegged mortise and tenons found in a very bad state of preservation and only by the hooked scarf that joins the keel with the stem. As our knowledge on the evolution of shipbuilding during the 5th and 4th centuries BC is scarce, the Mazotos shipwreck adds meaningful pieces to the puzzle, especially if we compare it with the only 2 fully excavated ships of the period so far, the Ma'agan Mikal and the Kerimia. But I have to stop here, and I promise I will have more to report in future conferences, hopefully not on Zoom, but on real stage. And I will return to the first years of excavation. Based on the results of the Marine Geophysical Survey, the excavation started from the southern end of the site where a strong magnetic signal had been recorded. Soon, the lead cores of an anchor were revealed at the starboard side. And during the following years, an almost identical bower was exposed at the port side as well. Their wooden parts have been destroyed, but the 2 lead cores of the stock, approximately 50 kilos each, were preserved. 2 incrustations, the iron arm tips of one of them, were found in situ, south of the stock, and gave us an indication of the anchor's size. These finds, along with the shape of the amphora concentration, left us little doubt that the southern end of the assemblage was the bow of the Mazotos ship. A first impression we had before any excavation took place was that just by looking carefully, at the height difference of the amphora concentration, we could distinguish the area that the foredeck must have occupied. For ships of this period, there is no other archaeological evidence regarding the foredeck, so it was important to collect as many evidence as possible. It took us 3 field seasons to complete the excavation of the bow area, and what came to light had a rather disturbed stratigraphy, with many amphorae either broken in situ or lying on their sides. None of them was standing. This gave a very different impression than the one we had from our pre-disturbance surveys at the main hold, where we had distinguished 3 to 4 layers of intact containers still standing. We know that the ship listed to its starboard side and some amphorae, possibly from the higher tiers, lost their original positions, but did not necessarily break. And here I can show you a very instructive plan of this procedure made for another site, the Roman shipwreck of Madrag de Gien. The situation at the bow of Mazotos indicated that when the boat reached the seabed, the impact of the crash was much stronger there at the bow, and no doubt the foredeck collapse added to the extent of the destruction. Mapping in detail this disturbed situation was a challenge that photogrammetry and 3D visual applications allowed us to take on. Most importantly, it allowed us to delve into the stratigraphic permutation, i.e., the detection of the temporal relationship of different units of stratification. As we saw earlier, the hull remains under this particular untidy assemblage were found poorly preserved. The keel was there, but partly destroyed, and the planking was almost completely gone. So our only way to approach, even remotely, the internal stratigraphy of the ship's bow was through spatial analysis of the artifacts. The easier part was to establish that 2 layers of amphorae were stowed in this part of the ship, and you can see them here. Reconstructing how they were stowed was a slightly more elaborate effort. We started with the most destroyed part between the 2 bowers at the port and starboard side, the space between the stars, the red stars on the screen. No artifacts were found beneath the anchors, so most probably they were stored outside the gunwale, not on the deck. When the ship tilted westwards, the port anchor must have moved toward the keel, but the starboard one fell on the seabed and most probably next to the ship's bilge. If this is correct, then its position can help us calculate the maximum width of the hull's bottom between the 2 bowers, which should have been no less than 2.3 meters, or double the current distance between the starboard anchor and the keel. A total of 42 excavated amphorae in this small area had broken, but had not spilled farther off the main concentration, most probably because the anchors created some kind of barrier. The first thing we needed to establish was the arrangement of these 42 amphorae in 2 tiers. To this end, we took into account their stratigraphic units, if they were found on top or under others, as well as their orientation and position in relation to the keel, port, starboard, or in the middle. This was a long table. I know that it's impossible to read on the slide, so I blew up a couple of lines on the top, which maybe can read clearer. For the digital stowage, we used 2 types of amphora models. You see them on the bottom right on your slide. The ones we call actual models are based on the specific dimension of each one of the amphorae. The average models were used for amphorae that were found in a fragmentary state of preservation, They concerned only large and small key and amphorae and were created based on the average dimensions of the respective sizes recovered thus far from the rest of the site. Based on the results of this analysis, 6 rows of amphorae transversal to the keel axis were placed on the lower tier as close to the original find spots as possible. 6 containers in the first row, 4 in the second, 6 in the third, and then 5, 3, and 2 in the remaining rows. The distance between the containers of the first tier was decisive for the next step, because it determined how far down the upper tier can be set into the lower one. For this, we took into account the use of dunnage, i.e., the dry bushes that were put between the amphorae to avoid breaks, something like a more natural bubble wrap. This is for the Matraque de Gien, and these are some of the numerous such twigs found during the excavation at Mazotos. Although in well-preserved shipwrecks such as this one, there is a good chance that evidence about this distance between the amphorae can be found in the center of the hold, and this is how we try to do it here at Mazotos. It remains difficult to detect this distance at the extremities. Still, we tried it through accurate mapping of the relative positions, even of the fragmentarily preserved ones at the bow, and they all showed that an average distance of around 10 centimeters between the containers was likely to be the case. Conventionally, this distance was kept for the entire lower tier at the bow, although most probably no such strict rule was applied in antiquity. Based on this analysis, we determined that 26 amphorae were stowed in the lower tier and 16 at the upper one. As you see, we tried different kinds of digital stowage. One on the left that took into account the specific find spots, and 2 others that did not. For these, on your right, abstract arrangements, only the same one amphora model was used repetitively in a regular configuration in staggered rows here, without taking specific find spots or shapes into consideration. In fact, similar patterns, regular ones, are often applied for the reconstruction of sites where the ship's internal stratigraphy is completely disturbed. We believed, however, that the one on the left, this one, should be closer to the original arrangement. If yes, then the covered compartment of the bow must have been at least 1.7 meters high, 2.6 meters wide, and 2.5 meters long. Interestingly, the minimum width and length were different in each stowage pattern that we see, but the height, 1.7, remained the same. Now, why was this copious and tedious exercise of any importance? For a number of reasons, I think. First, although that the reconstructed cargo block can only be considered indicative of the compartment's minimum size, it gave us clues on the ship's lost space, something that will be crucial for any reconstruction of the hull in the future. Second, it also helped us test and optimize our mapping and documentation methodologies, focusing on the site's microstratigraphy. Although costly in fieldwork time, meticulous daily recording played a key role in this digital experiment because it was exactly what allowed us to have the accurate location of both intact and broken amphorae. And third, this reconstruction made us think more about the ways the crew interacted with the ship's confined space, and especially the lading processes in the compartment under the foredeck. For instance, The maximum height of the stowed amphora was 1.7 meters, but more space should have been allowed between the top amphora layer and the deck above to enable safe loading and maneuvering. How much, we do not know yet. It is also uncertain if there was a hatch or another opening to facilitate stowage from the deck, and we cannot determine what they did when they had to rearrange the cargo or accommodate non-standard containers. Also, parts of the ship's gear that wouldn't jeopardize the cargo but needed to be within reach, such as wooden tools, nets, or ropes, could have also been stored there and filled the irregular gaps we observed. Moreover, the stratigraphic analysis of the bow destruction layers raised several questions about the site's formation processes and underlined the degree of uncertainty that they imposed on any attempt to reconstruct the space of the ancient ship. In order to detect these processes, we looked closer for any clues regarding post-deposition phases, very hard to find in the airlifted sand at this depth. The zone right above the seafloor, also known as the benthic zone, is where most of the biological activity takes place at a macro, medium, and micro level. The interface between the highly oxygenated environment above the seafloor and the low to no oxygen environment within the sediment just underneath creates a distinctive horizon, easily detected on the amphorae as a zone of biogenic encrustations. So the horizons defined by these traces can act as proxies for the identification of subsequent seafloor levels at a shipwreck site. Based on this observation, we decided to investigate further if the arrangement of the amphorae as we excavated them had changed during possible post-deposition episodes of the hull's gradual collapsing or other extracting filters or scrambling devices. In order to plot these biogenic and marine aggregates on our site model and acquire georeference spatial information on their location, we needed to record them in 3 dimensions. This was the subject of the postdoctoral fellowship of Dr. Massimiliano Secchi, who copiously documented photogrammetrically more than 300 intact or partly preserved amphorae and populated the site model with the sediment and biological information. So a different spatial analysis took place here based on which of the 2 seafloor levels were reconstructed, based on which 2 seafloor levels were reconstructed that reflect the sediment accumulation at the site. The lower one must represent a first phase of stability achieved soon after the wreckage, and the upper layer almost perfectly matches the present-day seafloor and appears to represent a second phase of stability achieved more recently after a slow sedimentation process that lasted for centuries. So what we managed to establish was that the destruction layer that we have documented at the bow was indeed one episode that happened right or soon after the wreckage. Scrambling devices had obviously acted, but not in ways that had significant impact on the current location of artifacts. In other words, we had based the reconstruction I discussed earlier in sound grounds, I think, as far as the artifacts' positions are concerned, at least. I could not finish this discussion on methodologies without a word on finds and pottery, although I promise it would not take long. Since the beginning of the project, we have given more than 1,700 individual numbers to finds. These vary from intact amphorae and anchors to individual olive pits, grape seeds, or twigs. Amphorae are the most numerous and hence the more meaningful ones to quantify. Thus far, we have raised 261 amphorae, but these are minimum number of individuals, which means that the true number is higher. But the bulk of the cargo remains in situ. As you can see, half the side, which is the main part of the hold, with multiple layers of amphorae, this one here, has not been excavated yet. Many students, volunteers, even fellow archaeologists often ask why it is important to keep all these identical pots. They say that studying only few would be enough for what we need to know about the wreck. Well, I think this is not true. Apart from the date, the last journey, or even the special analysis of the ship that I talked about earlier, homogeneous cargoes of contemporary transport containers of the same type, like this of Mazotos, provide a unique opportunity to address fundamental issues, not only in maritime archaeology, but also in pottery studies and ancient economy. Key and amphorae were a largely exported type of Greek maritime transport containers associated with one of the most prominent maritime sites in the Aegean. Prominent maritime city-states, Amphora workshops were probably one of the key side industries of maritime commerce because the produced containers ensured the product's safe handling in the ship and facilitated transactions. Kilns, however, have proven to be rare discoveries, and the material from consumption sites, urban or rural settlements and harbors is often too fragmentary and heterogeneous. Cargo assemblages represent a key phase of transport amphora biographies, and here you see a very good diagram which stresses how many stages these biographies may have. So cargo assemblages are very important because most of the containers in them are found while they're still in their prime use or after the completion of production, sealing, filling, stopping and stowing in the ship, but before consumption. So we can ask some very interesting questions with them. For example, how many pottery workshops might have provided containers for a single cargo? To what degree were their sizes and morphology standardized? How were they sealed? Were they reused or not? Etc. During the current study season, a morphological analysis is underway. So each one of the recovered amphorae is examined in order to identify their characteristic features and record traces of their manufacture and use. We hope that quantification of these results will have been completed early in 2021 when a series of scientific analyses of the fabric have been planned. The last aspects of the Mazotos shipwreck I would like to touch on before I close this presentation is the project and its people. During the 12 field seasons, survey and excavations ones, a total of 151 divers have participated in the project. One of them was Mark Beatty Edwards, as he said in the beginning. Archaeologists or other scientists, students and volunteers. No season had more than 50 divers, but most of them took part only in 1 or 2 seasons. And a lot came only for just a visit. There are more participants that would make this list much longer, such as non-divers and students, to whom I owe a lot. The diving and nautical logistics of our excavations are such, however, that I feel the need to stress how absolutely necessary the presence of volunteers or avocationals was from the very beginning. Each one of their dives counted. there would be no way to afford an open-ended project for 13 years now without the support of these people. In the beginning, we thought that this was a weak point. The fact that there were no adequate funds to support a paid team of professionals to carry out the hard work. But now I think that it has become one of the project's strengths. A large number of international divers have been trained at the site, and a growing number of local divers have become aware of how important it is to protect wreck sites. They have acquired the skills to assist with archaeological investigations and have come to acknowledge that maritime archaeology is not about just raising old artifacts from the sea bottom. It's not even fun diving most of the times. Building on this particular aspect of the project, 2 public awareness activities have been organized in collaboration with the Nautical Archaeological Society. The first was a field school for technical divers, which took place during the 2016 field season and proved to be a learning experience from everyone. It was the first time that a field school had been held on Mazotos Shipwreck and remains the only one thus far. It was also the first time that NAS had run a field school or such a deep site. We all realized that it was not easy to create an effective class on a complex and deep site, so we did not repeat the field school. In 2019, however, we tried something different with the Reaching Out project. We offered the opportunity of engaging and enlightening visits to local divers that had heard about the wreck during all these years, but did not have the chance to visit the site or take part in the project. The results gave us more food for thought. We all know that divers like to dive different sites, and a free-of-cost dive at a 2,500-year-old wreck is certainly something that many would like to try. A hard-to-answer question is how much were these visitors actually interested in the knowledge that we were trying to convey through the experience, and how much of their interest was about the experience itself, the diving experience, I mean. Both is the easy and possibly the correct answer, which has made us start thinking of more effective ways to bring the public closer to what we do at Mazotos. In any case, what was actually confirmed during these activities is that public awareness needs time, perseverance, and inclusiveness. The results of individual activities become significant if they are placed in the context of a more systematic effort not to isolate the wreck from the society. And this effort includes activities that not always concern divers, such as several classes of undergraduate archaeology students that had the opportunity to spend a day on board over these years, or those that contributed to the copious and log task of digital documentation at the office. I should also mention community-based work at the village of Mazotos, the Cypriot maritime bus that drove around Cyprus for 1 month in 2017, and a recent exhibition at the Thalassa Museum, Agia Napa, which was part of an EU-funded project on virtual reality applications in maritime archaeology. There will be no time to thank all participants, all these peoples, all our supporters, friends, and sponsors that have helped the Mazotos shipwreck over the years. But it's important to say that as the project is becoming of age, its bonds with the contemporary society of Cyprus and the world of maritime archaeology are getting tighter. Like all excavated shipwrecks, it is affecting people's careers, it is offering unique experiences, but also demanding effort and resources. And what is more, it is gradually becoming itself a vehicle that takes us further to new challenges. Well, this is what I call nautical archaeology. I thank you very much for your attention.